Bigger isn't always better, and faster doesn't always work. In today's circuit board assembly, it's increasingly important to understand how our job should be done. Each person is important to the quality of the finished product. In this video, we will discuss the people, the tools, and the materials used to attach components to printed wiring boards using hand soldering techniques. In the next video, we'll discuss hand soldering techniques and look at some acceptable and rejectable soldered connections. The purpose of soldering is to create an electrical connection that is sturdy and will last. In this hand soldering series, we will show you how to make high-quality hand-soldered connections. A very important part of this process is the person that does the job. You must be trained to understand many different hand soldering situations. As in most jobs, your attitude is very important. The quality of the finished product can be greatly influenced by how much you care about the work you do. A solder joint that opens up occasionally is called an intermittent failure. In some products, this can be annoying. In some products, this failure could be dangerous or even fatal. Many people depend on the quality of the assemblies you work on. We'll start by looking at the hand soldering area, an important tool in the hand soldering process. The workbench and the area around it should be kept clean, well lit, and uncluttered. All dirt, grease, oil, solder splatter, wire, insulation cuttings, and other debris should be cleaned away often. Use a brush or rag so you don't hurt your hand. Any of these materials could contaminate the assemblies you work on. Food or drink at the workstation can also be a problem. Ingestion of the chemicals used in the flux or even the lead in the solder can poison you. Never eat at the soldering station and wash up before you eat. Contact with food can also cause solder joint contamination. Another problem at the hand soldering station is silicone-based lubricants, hand creams or lotions. These substances will contaminate a solder connection and should not be used. Ask your supervisor which hand creams are acceptable. Another problem associated with your work area is the static electricity created whenever two dissimilar materials rub against each other. Here's an example. When papers are rubbed across the workbench, a charge is generated. This static electricity can build up in your body. The spark you see, hear, and feel when you touch something grounded is that charge leaving your body. Some components are very sensitive and can be damaged by even a small electrical charge. Your work area should be cleared of all non-essential items that can generate a charge. Grounding mats on the floor or anti-static mats on the workbench surface will remove any electrical charge. Wrist and foot grounding straps, grounding shoes, and aprons are other tools that will drain a charge. The wrist strap is the primary and most important grounding device and should be used whenever possible, regardless of what other methods are being used. All of these appliances need to be checked on a regular schedule to make sure the user is properly grounded. Another recommended safety measure is the fume extractor. This apparatus removes the vapors given off during the hand soldering process. Now let's discuss the soldering irons used to transfer the heat needed for hand soldering. There are many types of soldering irons, with interchangeable tips that vary in size, shape, and temperature. All soldering irons should be electrically grounded. This will protect you from electric shock and will also keep the components on the board from being damaged. The irons used vary in wattage. There are 4 common types. The micro type uses 20 to 30 watts. A medium size that uses 30 to 45 watts is the most common iron in PWB assembly. There also is a large iron which uses 60 to 100 watts of power. The 4th type is the temperature-controlled iron. It has the advantage of maintaining tip temperature during soldering operations, no matter what the load is. An iron that produces a tip temperature of 370 degrees centigrade is sufficient for most of the hand soldering we do. In certain situations, a 315 degrees centigrade tip may be preferable since some boards and components are more susceptible to heat damage than others. A 425 degrees centigrade tip temperature is often used on thicker, multi-layer boards where more heat is needed. The shape and size of the tip on your iron is also very important. The amount of heat that is transferred to the parts that are being soldered depends not only on the temperature of the tip, but also on how much of the tip touches those parts being connected. Pointed tips, such as the conical tip, put the heat into a small area. These tips would be used with small lands in areas that would need very little solder. A screwdriver tip, or this chisel tip, will transfer more heat because a larger area contacts the parts to be soldered. This type of tip would be used in larger connections. Remember, the general idea is to complete each solder connection as quickly as possible. 3 seconds is an average time to complete a hand soldered joint. Excess heat can spread to adjacent areas of the board and cause damage. Damage can also occur inside the board. This is a plated through hole that has been damaged by excessive heat. As the area was overheated, different expansion rates for the metal and the other board materials caused this separation. This interior problem could never be seen during visual inspection. The wattage of the iron and its heat recovery rate, the size and type of soldering tip, and the amount of time the connection is contacted determine how much heat is transferred. We want to use the minimum amount of heat that will still produce a good, complete solder connection. Now we're going to ask a few questions concerning the information we've covered so far. Since there are differing opinions concerning various aspects of hand soldering, this will be an opportunity for you to ask questions of your instructor and become aware of your company's policies. There are many different types of solder wire used in PWB hand soldering. The solder we'll use in this video is a combination of tin and lead. These tin-lead alloys are used because they have a lower melting temperature than the base metals they are joining. The temperature at which a tin-lead solder melts is determined by the ratio of tin to lead. The melting point of solder containing 60% tin and 40% lead is 188 degrees centigrade. This solder becomes soft, but not a liquid, at 183 degrees centigrade. Solder is not strong in this soft stage. Solder with 63% tin and 37% lead melts at 183 degrees centigrade and does not have this soft stage. It changes quickly from liquid to solid form. With a lower melting point, the parts to be joined don't need to be heated as much. Because of this lower melting point and also because it becomes hard quickly, 6337 solder is used often. It even has the special name eutectic solder. If a solder joint is cooling and the solder is not yet solidified, a bump or vibration may break, loosen, or otherwise harm the electrical and physical connection of the joint. With eutectic solder, the amount of time needed for the solder to harden is the shortest for tin lead solders. Another variable in solder is the flux contained inside it. Although not all solders contain flux, most of what we use in hand soldering does. The solder is a tube that surrounds a core of flux, like a garden hose full of water. The flux is a chemical cleaner used to remove impurities from the surface of the metals to be joined. These metal surfaces must be clean in order for the solder to bond with them. Metals that appear to be clean can have a microscopic coating of oxides. These oxides form simply by the metal being in contact with the air. Oxides can prevent the solder from reacting and bonding with the metals that are to be joined. Here we see non-wetting. If there is no wetting, both the electrical and the physical bond will be non-existent. An important prerequisite for a good solder joint is clean lands and clean component leads. Removing oxides is the intended job for the flux. As a solder is heated, the flux melts first, flowing ahead of the solder. The oxides are then chemically reduced, increasing the ability of the surface to be wetted. The solder then melts and flows over the joint, beneath the flux, allowing the liquid flux to carry the impurities away. The solder then combines with the metal of the parts to be joined. This combining of metals occurs just at the surface where the different metals touch and is called intermetallic. If this bond is sound, the result is called wetting. We will be discussing wetting more in the next video, but now let's find out more about flux. We commonly use a Rosin flux in hand soldering. Some shops may even apply flux to the joints before soldering with a flux core solder. One type of flux we commonly use is designated by the letter R. This is a pure water white rosin that is mild and practically non-corrosive. Corrosive means that the flux or the flux residue may react with and deteriorate any metals it remains in contact with. RMA is a mildly activated flux and more active than R. This means it will clean the metal surfaces better, but also has more residue activity. Flux residue can be sticky and cause dust and other contaminants to stick to the board. The residue and the contaminants can be corrosive or conductive and may cause electrical leakage or a short circuit. Rosin-activated or RA flux is even more active than RMA, but is also more corrosive. RA must be thoroughly cleaned from the board to prevent possible electrical failure. RSA is rosin superactivated flux. This flux cleans very well, but has an extremely active and corrosive residue that must be totally cleaned from the board. RSA is used in situations where it's particularly difficult to reduce the oxides from the base metals. Water-soluble and synthetic activated fluxes are slightly corrosive, but are cleanable using aqueous systems. Another method of classification of fluxes is found in the IPC SF 818 specification. Here, flux is classified according to the flux activity. This method classifies the ability of the flux to remove oxides and the need or difficulty of removing the residue from the board. 3 properties to look for in a soldering flux are: first, it must be strong enough to clean the oxides from the metals to be soldered, but not damage any components. Second, the flux must be thermally stable. This means that it must be able to clean the metals at the high temperatures reached in hand soldering. And third, if the flux leaves any corrosive or conductive residues, these must be removable. We will discuss flux residue removal in Part 2 of this video series. The better a flux cleans, or the more active it is, the more likely that the residue will create a problem. Still another choice regarding solders is the diameter of the solder and the percentage of flux inside the solder. With the larger diameter, there would be more solder available, but in some situations, that would be too much solder. With the larger percentage of flux, there would be more cleaning action, but there would also be more residue. As you can see, there are many options in the materials that are available. You will be told which solder to use for each application. Now let's review some of the information on the solder we use to connect electronic components. In this training video, we've given you a lot of information about the tools and materials used for hand soldering in the assembly of printed wiring boards. The people that do this work need to know not only how the job is done, but why the tools and the materials do what they do. Here's an example of one setup that could be used in a typical hand soldering operation. We have chosen a temperature-controlled soldering iron set to produce 370 degrees centigrade at the tip. The tip is a conical shape and the appropriate size for the work we are about to do. The solder we have chosen is 6337 eutectic solder with the RMA flux core of 3.3%. You can see that there are hundreds of other possible combinations of irons, tips, solders, and fluxes. Each company has policies or guidelines for making these decisions. If you are unaware of the requirements of your job, ask your supervisor. If your tools are properly chosen and maintained, and if you use the proper flux core solder for the job, the quality of your work will depend upon your attitude and your training and skill. In tape number 2 of this series, we will discuss the nuts and bolts of how to hand solder components onto printed wiring boards. We will also discuss tinning the soldering iron tip. We'll also talk about cleaning fluxes off the boards and how to recognize various defective soldered connections. If you have questions about hand soldering, now is a good time to find out who at your workplace can answer them.